What is going on, everybody? Thank you for tuning back into my channel. Welcome. Today, tonight, I thought, what would be better than to put everyone to sleep by teaching you a little bit of math. A little bit of math, just a little bit of math. In particular, trigonometry. Now, trig is one of those subjects that I can do a excessively long video about, but I'll keep it, short and sweet today. But if you guys do want a longer video, I can, definitely try that out. But anyway, that being said, why don't we jump into today's lesson now? I do apologize. I thought that you might be able to hear the sounds a little bit better as I was writing, but they're a little faint. So, yeah, hopefully you can get the writing sounds in, but I'll still be kind of whispering anyway. Okay, so in today's lesson we are going to be learning trigonometry, or trig for short, right? Trig. So, I do have a couple of things for us to go over first. So before we can really dive into the actual the actual trig, first you have to understand the trig functions. Okay, you need to understand the trig functions. So I apologize if it's a little bit small. I don't write particularly big, so but I'll try my best. Anyway, in trigonometry, you have a total of 6 trig functions. You have sine, you have cosine, tangent, you have cosecant, secant, and cotangent. And by the way, I am of course writing the abbreviations of the word in trig. Whenever you see the problems written, you won't really see them written as, cosine, tangent, they're never spelled out, right? So they're always used in this abbreviated form. So that's just the way I'm writing it. But anyway, so these 6 trig functions can be used in a couple of different ways. The first way that we can apply them is on a rectangular coordinate system, okay? On a rectangular coordinate system. Now basically that's just a way of saying, whenever we're on a rectangular coordinate system, it's basically just like the regular x and y plane, or x and y axis that everybody's kind of familiar with, right? And basically, if we are on one of these, if we're on a rectangular system, we can imagine this as a triangle right here, where this is x, this is y, okay, and this is r. So this is one side, this is your bottom side right here, x. This is your height, if you will, or just your other side, y. And then r would be your hypotenuse. So, if you've ever worked with triangles, you'll know about hypotenuse. And we use it sort of the same way in trig. Going back to sine, when you're on a rectangular coordinate system, your sine is y over r. Y over r. For cosine, whenever we're on a rectangular coordinate system, it's x over r. For tangent, it's y over x. Now, cosecant is like the reciprocal of sine, or reciprocal of sine, in a way, or rather I should just say it's just the opposite of sine. That's what I'll just say, yeah. And what I mean by that is it is r over y instead of y over r like sine is. Similarly, secant is r over x, just as cosine is x over r. Secant is backwards, it is r over x. And then finally you have cotangent, which is the opposite of tangent. So as you might have been able to guess, x over y is your cotangent. Now, if we were on a right triangle, so let's just say that we're still on the same, or I'll just draw another one right here. Let's say that we are on a right triangle right here, and this is our angle theta right here. Theta is a very common symbol, Greek symbol, used in trig for typically to mark an angle. So if we were looking at this right triangle from this angle theta, our sine of theta, okay, so the sine of theta would be, oh, by the way, let's go ahead and we're gonna call this again same, y, x, and r. But when we're on a right triangle, these are typically referred to as opposite. And by the way, I mean opposite to your angle, right? Because your angle is on this corner, and this side is opposite to it. Down here would be your adjacent. Would be your adjacent side, because it is adjacent to this angle, right? It's right here. It's not opposite, it is adjacent. Okay. And then this right here is going to remain as a hypotenuse. Alright, and by the way, I just kind of did it like this simply, but, you know, they could be wanting this angle up here, you know, in which case, your adjacent would be over here versus over here, right? So it all depends on what angle it is that we are looking for, but in this case, this is the angle we want. It makes it a little bit simpler. That's how I learned it. And anyway, when we're on a right triangle, your sine is opposite over hypotenuse, okay? Oh, sorry, that is opposite over hypotenuse. So again, that's why I kind of kept the letters here. I kind of kept the letters because I wanted you to see that they are in fact the same thing, but you know, right here they're just known as opposite, adjacent, and hypotenuse, right? So as you might have guessed here on cosine, it is adjacent over hypotenuse. Your tangent y over x is opposite over adjacent. By the way, all of these definitions and identities that we'll go over, these are all relevant because these are pretty much all used whenever you're doing any problems. Any problems involving, you know, trig, basically. So, cosecant here. So, in cosecant, we're at hypotenuse over opposite. Secant is hypotenuse over adjacent. And finally, your cotangent is adjacent over opposite. Just like these. And finally, there is one more way that we can use these trig functions, and that is, of course, on a unit circle. On a unit circle. What's it called? Yeah. There we go. Yeah. Unit circle. Yeah, so whenever we're on a unit circle here, the way that we're gonna see sine is as your y, just your y. Sometimes you're asked to find a certain point or an angle for sine, and in terms of a point, sine is your y on an x and y point, and cosine would be your x. So yeah, basically whenever we're talking or whenever we're doing problems involving, you know, plotting a point of whatever it may be, then we use cosine for x and we use sine for y. Tangent is still y over x. Okay, so just like if we were on a rectangular coordinate system, we use y over x for the tangent, and for cotangent we also use x over y. Now the reason that I kind of skipped over cosecant and secant is because these are a little bit different. In terms of the unit circle, your cosecant secant is actually 1 over y, and your secant is 1 over x. Okay, so it is I mean, they're not really different, right? It's basically just, the opposite of x would be 1 over x, so that's basically what it is. Yeah, so these right here are all your trig functions and, trig function definitions. And all of these are used to come up with different identities and just all kinds of stuff. I'm trying to think of stuff off the top of my head, but anyway, moving on. I wanted to show you maybe one little problem where we can use trig to help us solve a problem. And I'll come back and maybe do some more identities, but I figured I didn't just want to be writing down identities and definitions the entire time, so we'll call this an example. We'll call this example right here, and I just got a random example for us to work on. So what does that look like? So we'll say we have a triangle, right? And we'll call that A, B, C. And I can see that this one's going to be a pretty easy problem, but anyway, we can use trig to find like the different sides or angles. Now, in this case, oh snap! Sorry about that. My laptop almost died over there. I'm using it to get me the examples for the problem. Okay, yeah, anyway, so that's good. Okay, so in this case, it's super easy because, well, we know that triangles add up to 180, so in this case, we already have two angles, right? So, yeah, so we know that angle C is equal to 130 degrees, so that one was pretty simple in terms of finding that third angle. But say you wanted to find one of these other sides, right? So your P corresponds up, your lowercase p corresponds opposite to your capital letter B. Likewise, lowercase c goes opposite of your uppercase c there. Okay, now what we can do here is we can actually use something known as the law of sines. Now the law of sines, says that your side A over sine of angle A is equal to side B over sine of angle B is also equal to side C over sine of angle C. Okay, now the way that we can actually apply this here, say we wanted to find B, right? Well, what do we know? We know the angle of A and we know the side A, right? So we need to know one of these. So in this case, we have 45 over the sine of 30 degrees. Oh, and by the way, this is kind of like also where that whole opposite and adjacent, hypotenuse, all of those functions and what they mean come into effect as well, right? Because whenever we're talking about the sine of 30, we're talking about the opposite side, right? We're talking about y, which is 45, right? So, little things like that that's when you need to kind of know those functions. But anyway, what's it called? Moving on with the problem here. Where were we? Alright, so we were trying to find b. So, b, now we know the angle of b though, and that is 20. Now that we're here, we can do a little bit of cross multiplication. And you're gonna end up with b is equal to 45 sine of 20. Oh, that was horrible. Sine of 20 degrees over sine of 30, which is, I'll round it off. Get my calculator here. Man, we are in degrees. Cool. So we can just do this. So 45 times. I'll kind of hold it right here. 45 sine of 20 divided by the sine of 30. There we go. So we'll round it to 31 meters. So we know that your side B is 31 meters. Now likewise, we can use this exact same angle and side to find C. So once again, because again it's also equal to C over sine C. So is equal to C, and again we know the angle, which is 130. Cross multiply, and we end up with and I'll get to that in just a second, but for now, just so you can see, 45 sine of 130 divided by the sine of 30, and there you go. Side C is equal to 69 meters. Right, and if you look at it, it makes sense because B is your smallest side, and it's 31 meters. Then A over here is your second highest side, which is 45, and then this, your biggest side, is 69, which is in fact the longest one that we have. So that is one way that we can apply, some trig knowledge to find in this case, the sides. What's it called? Yeah, in this case, the sides and an angle. Yeah, I mean the angle is pretty easy though, because all you have to do is make sure that the triangle adds up to 180, basically, and that's it. Alright, let me see. Just kind of think of an example right here on the fly. So say you had say there was a building, say you're like standing right there, and it's horrible, he's not even touching his body, okay, say you're standing right there, and I don't know, we know you're looking up, and you know that is, I don't know, 25 degrees, let's say. And we know that this building, for example, is, I don't know, it's 100 feet tall. When we want to find out how far away you are from there, we can use a basic, trig function to solve that for us. So in this case, we want to find x, so we can use tangent. So tangent, because we know one side, or we know y, and we want x, so we can apply that one. Tangent of 25 degrees is equal to 100 over x. Okay, now let's go ahead and work this out. If we multiply, we want to isolate x basically, so let's multiply it over here. And now let's go ahead and divide out that whole tangent of 25 degrees onto the other side. Okay, now we can see what that gives us. So it looks like we would be at using what's it called? Using trig, we can find different sides, you know, like like in this case, you know, if you wanted to find out how far away you are, well, you're 214 feet away. So trig helps you find solutions to some pretty interesting things that are quite useful in some professions. But yeah, I hope that you all found this nice and instructive, possibly boring, although I hope it was boring in a good way. And thank you all so much for watching. If you liked this video, then definitely make sure to go ahead and subscribe, drop me a like, leave a comment, and I will see you guys on the next video. Bye.